Hi, welcome to my video on graphing polynomial using the x and y intercepts, increasing or decreasing intervals, maximum, minimum points, and the concavity. And this is number 2. Number 2. Here we go. Graph y equals negative x to the fourth plus 6x squared minus 5. A quartix, and a quartix is, I call a quartix like a McDonald's or a Wendy's if you're having a hamburger. So let's look at, we want to find the x and the y intercepts. So let's look at, first of all, we're going to see if we can factor this. Notice this is x to the fourth and x squared. Might be able to factor it. So we'll take the negative out first, because when I work my math, I like to have the leading term positive. So I have a positive x to the fourth. And now I notice that I have an x squared here, factors of 5 to give me a 6 or 5 and 1. So it looks like I'm going to go x squared, factors of 5 to give me a 6 are 5 and 1. Because the product is positive and the sum is negative, that means I have to have two negatives. So it's a negative 5 and negative 1. So if you did the FOIL here, you would get this trinomial. So that means we have, this is the difference of two squares. So that's x and x, square root of 5 and the square root of 5. And we got a plus and a minus. This is also the difference of two squares. So we do two brackets, x and x. Square root of 1 is 1. And we have difference of two squares, so this is a plus and a minus. So that means that if, according to this, if you look for your x-intercepts, so if you make y equal to 0 in this equation, so the values of x, the x-intercepts, are going to be negative root 5, positive root 5, negative 1, and a positive 1. So these are the x-intercepts. So the x-intercepts are plus or minus 1. So let's put them right there. The square root of 5 is around 2.2. So positive 2.2. So there's a 2. So let's say it's right there. And this is negative 2.5 right there. So this is negative 1, 1. This is root 5. And this one is negative root 5. So now, according to this equation, if I let x equals 0, I'll find a y-intercept. So the y-intercept is, we have a 0 here, we have a 0 here, minus 5. So that gives us a negative 5. So when x is 0, y is negative 5. X is 0, y is negative 5. That's right down right here, right on the end of this arrow. So this is the point 0, negative 5. That's the where the graph cuts the y-axis. Okay, now that we have found all that, let's do the derivatives. And what about if we do y prime? So y prime is, this is negative 1 times 4 is negative 4x cubed. Derivative here is 2 times 6 is 12 plus 12x. Derivative of a constant is 0. So this is the first derivative, and the first derivative gives us the slope of the tangents. So if we make derivative equal to 0, we'll find out where the slope of the tangent is 0. So that means we have a negative 4x cubed plus 12x equals 0. And I have an x common and I have a 4 common, so I take out the negative 4x outside of x squared minus 3. So I have a negative 4x, and this again is the difference of two squares. So it's an x and an x, square root of 3, root 3 root 3, and that's a plus, and that's a minus. So the values of x that make the y prime equal to 0, the slope of tangent 0, the values of x are x is 0 here, negative root 3 here, and a positive root 3 here. So these are the values of x that make the slope of the tangents 0. And if we take those values and plug them into this equation, let's see what we get. So again, we put a 0 in here. We did a 0 already once, and we got a negative 5. So that's a 0 minus 5. So that's one of the points that's going to be where the tangent is 0. So this could be a maximum or minimum point in the graph. We'll keep going. What about if we do a negative root 3? So we have y equals, we do a negative root 3 in the place of x. And so that's negative root 3 to the 4th power. So negative, it's a 4 negatives is a positive, so we know it's going to be a positive. So we got root 3 to the 4th power. So we could go root 3, root 3, root 3, root 3. Root 3 times root 3 is 3. This root 3 times root 3 is 3, so that gives us a 9. That's one way to do it. Another way to do it would be to take the root 3 and call it 3 to the 1/2. Because the square root is, the power of 3 is 1, and that's a 2, so that's 1/2. So that's becomes 3, 1 power of a power 1/2 times 4 is 2, so 3 squared is 9. So we could have got 9. So that's a 9, makes it negative. And we got negative root 3 times negative root 3 is positive 3. So 6 times 3 is 18 minus 5. So that gives us 9 minus 5, so that's a 4. So this point is negative root 3, 4. And if we do the root 3, so let's move this down right here. So if we do root 3 to the 4th plus 6 root 3 squared minus 5. So root 3 to the 4th is the same as negative root 3 to the 4th. That's going to be a negative 9. Root 3 squared is a 3, so that's going to be 18 minus 5, so that's a 4. So that's root 3, 4. So these are the points where the slope of the tangents is going to be 0. So negative root 3 is here, and negative root 3, oh, that's root 5. Root 3 is approximately 1.7. So root 3 is a little bit more than a half. So root 3 here giving us a 4. So this point is up approximately right there. So this is the point, root 3, 4. And negative root 3 is almost a negative 2. So it's a negative 1.7 up to a 4. So we're like negative 2, right? Okay, yep, right there. Again, this is approximation. So this is a negative root 3, comma 4. And if we look at that number line, if we look at this number line at negative root 3, we look at the 0, and we look at root 3. So this is y prime, which is based on these where the values of x are going to be 0 for the tangents. So if we put a 2 in here, put 2 in, let's take some numbers, 2. Let's put a number in between 0 and 3, which makes it's called a 1, easier number. Let's put a negative 1 here, and let's put a negative 2 here and see what the slope of the tangents are going to be. And put a 2 in. we put a 2 in this expression here. That's a negative, positive, and positive. So this is a negative, positive, positive. So that gives us a negative. Put a 1 in here, we get negative, positive, negative. So a negative, negative, positive, negative. Negative times negative is positive. Now we put a negative 1 in. What will we get? A plus or minus? A negative 1 here is positive. Negative 1 here is positive. And negative 1 here is negative. So that's a negative, positive, negative. I got to be careful. I just do it again. Negative 1 is negative 1 is a positive. Negative 1 is a positive. And a negative 1 here is a negative. So that's a negative. And put a negative 2 in. We get positive, negative, negative. So positive, negative, negative will give me a positive. So this is the slope of the tangents. This is the slope of the curve, or the tangents. So the tangent to the right of root 3 is negative. Between 0 and root 3 will be positive. Between 0 and negative root 3 will be see, this number, this should go right here, because I'm talking about between 0 and negative root 3. So there it is, negative. And on the left side here is a positive. So, again, because I know that this is negative, it will come up from the bottom. So the x-intercepts are here, right? 4 of them. 1, 2, 3, 4. So this is coming up from the bottom, going up, hitting here, and so the slope to the right of root 3. Sorry, the slope, to the right of root 3. So there's root 3 right there, and there's right here, this is put it right here, negative root 3. So the slope to the right of this is negative. So that means to the right is negative, so that means it's coming, if you think about it, it's coming up through the x-intercept, going up here, hitting this point, and it's coming down. And it's going to go down through the x-intercept, like this. And this is at 0, so it's hitting here, and it's coming back up. It's going to pass through this point of there's the x-intercept. So here it is, coming up through, hitting the maximum point, and coming down. So it's passing through. So there's the curve. It's passing through its intercepts here, root 5, 1, negative 1, and root 5. And at root 3, we have a maximum point. And at negative root 3, we have this maximum point. And at 0, negative 5, we have a minimum. And let's do the double derivative, y double prime. Y double prime on here would be a negative 4 times 3 is negative 12x squared plus 12. Derivative of 12x is 12. Y double prime is equal to 0. So we have negative 12x squared plus 12 equals 0. Negative 12x. We take the negative 12 out, and we get x squared minus 1 if we want to factor. So that's negative 12 x plus 1, x minus 1, difference of 2 squares. So the x's are at negative 1 and 1. So that's the double derivative is the inflection point. So we let the double derivative equal to 0 and solve it. So the inflection points are at negative 1 and 1. But negative 1 and 1 are the x-intercept of my graph. So if I put a negative 1 back in here, or 1 back in here, I will get my, let's put the 1 and negative 1. So x is negative 1. Let's put that in the, right here. So y equals negative 1 to the 4th plus 6 negative 1 squared minus 5. So negative 1 to the 4th power is 1, so that's negative 1. Negative 1 squared is 1, so that's a 6. And negative 5, so add them up, and you get a 0. So negative 1 gave us a 0. Negative 1 gave us a 0 right here. See? Because these are the x-intercepts. And if we put a 1 in, a 1 going into place of x here is going to give you a negative 1. A 1 going here is going to give you 6. So a 1 is also going to give you a 0. So that's 1 comma 0. Again, the x, when x is negative 1 and 1, which is this, we got the zeros based on the values of x to give you 0. So they're the x-intercepts. So these points are here and here. So these are the two inflection points. So this is an inflection point. This is when we made y prime, when we made double y double prime equals 0. We got the values of x to be negative 1 and 1. So these are the 2 points which are inflection points. So there's the graph. Notice it's negative. When it's negative, it's coming up from the bottom like this, starts down here and comes up. So it comes up through the x-intercept curves here. Before we did calculus, we couldn't find these points with a bending or curve, but now we can. So that's why the double derivative in conjunction with the first derivative gives us what the graph is all about. Again, to the right, it's negative slope. To the left, between these two, maximum and minimum is a positive. Here it's a negative slope, and here it's a positive slope. And this is a concavity flexion point. On this side we got, it's concave downward between these two inflection points. This is concave opening up, and between here it's, so this inflection point and this inflection point again, opening down, opening up. This is an inflection point, it's opening up and opening down. So again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.